Hey everyone, Mr. Newman here. Instead of doing a typical lesson, what I'm going to do in this video is I'm going to explain the project we're going to be doing tomorrow in class. So I want you to watch it, and even I have a few things for you to try before coming to class, which will make your data collection of your experiment go a lot faster and smoother, and you'll be able to finish within the class period. So first of all, this is a project which involves you measuring sound and how loud things are. So the first thing you need to do is you need to get an app that measures that. For iOS, you can find that link there, and Android is that link. Notice these links don't work in the video, but if you go back to Google Classroom, I should have attached this presentation, and you can follow along the presentation there as well. And yeah, click on those. If you don't have a device, then we're going to be doing random groups for this. So you will hopefully be assigned a group that will have a device and will work. So if you don't have a device, pay careful attention. That way you can help troubleshoot if something's going wrong, and you can help them figure out the problems. All right. So once I hope you have downloaded the app because I'm going to be talking about the app. So go ahead and pause the video and get the app first. All right. Now that you have the app, I want to make sure you can do these three things on the app. So those two apps were the two things. One last so other features are neat, and it's good to play around with them, especially like some of the things, well, on both of them, they've got graphs and stuff like that. It's quite fun. But these are the three main things you need. The play pause button, you need to see where the maximum decibels value is, and the reset button on the apps. And so I'm going to show you those right now. So on the left there, that's the Apple, actually it's for the iPad. I'm optimistic that it's also for iPhones, but hopefully you have something that looks like that. I recognize the irony that, yes, that's an avocado on the Apple app. That's an ad for an avocado. Well, it's not even an ad for an avocado, it's Geico, but whatever. The Apple on the left, and then that's Android there on the right. So the three buttons that you really need to know on these are the play or pause button. Oftentimes if somebody thinks it's not working, that's because the button is paused and the app is working, it's just paused. Then there's the maximum decibel value. And then there's also the reset button, which clears the average and the maximum decibel values, which is really helpful and important for when you want to measure sound. And we'll talk about that in a little bit. So first thing you're going to do when you get with your group is you're going to choose an experiment. So you can think about which of these you want to do. We are measuring decibels, and there are a handful of things that can affect how loud an instrument appears to a measurement tool. I want you to think of and bring to class any others, but these are the main ones that often crops up when we talk about this. The first is the number of instruments. So if you have 5 trumpets versus 1 trumpet, 5 trumpets will be louder. And the more trumpets you have, the more decibels of volume they'll be able to output. There's also the distance to the microphone. The closer you are to the microphone, the louder something sounds. And then, of course, something like how loudly the instrument is played is something that pops up. So we're doing an experiment on this, and we want 2 things that are immediately measurable. The first will be decibels, or one of the things will be decibels, and we want to see another thing that we can measure. If we had a whole band at our disposal, say full of trumpets, then we could have 1 trumpet play and measure their decibels, then have 2 trumpets play at the same volume and see how loud that is, and 3 trumpets, and so on and so forth, and we could do an experiment that way. There's a problem unless you're really good friends with Mr. Loy and want to go talk with him, our band director, then you might not have a band at your disposal right now at this period. So oftentimes students choose to do number 2 here, the distance to the microphone. That's a good one because you only need a single instrument, and you need a quiet room, and you need a way of measuring that the distance between the microphone and the instrument. This last one, how loudly the instrument is played, that's not really measurable except for by decibels. So we don't really have 2 different variables we can measure, unless there was some way of accounting for the amount of pressure on an instrument or something like that. But I've yet to find a group that has been able to give me a good quantifiable measure of that we can compare to decibels. Likewise, the number of instruments, I've had some success with students there, but that's typically where we have access to, say, several devices that are similar. So say we have a class set of iPads or a class set of Chromebooks, which we do have and you could use. What happens is you play one Chromebook and say, hey, how loudly is it? How loud is this? If it's turned all the way up, then two of them, and then three of them. And by play, I mean you go online and find, like, say, a piano app or a website that plays a single tone, and you can measure the decibels. So I would say probably not number 3, though you can think about it more. But number 1 or number 2 are the two that one of the two experiments you want to run. And really the second one is the most likely, though if there's a third, there are lots more things that affect how loud an instrument appears. So if you come up with something else and you can convince your group, feel free to come talk to me about it, and I'll let you do that. I would also recommend at this point, when you choose experiment, just running over to me real quick and just running the experiment by me to make sure everything sounds good, and that you guys are kind of in the right direction, so to speak. So what the other next step 3.5, I'm saying 3.5 because you need to choose an instrument, but you also need to choose a location. So some things to keep in mind: make sure you can be consistent. If you are a beginner on the trumpet, I would not recommend choosing you to play the sound, because you might play loud one time, then quiet the next, and even though you're moving away from the microphone, that might affect the how loudly you play. It will affect much more how many decibels are measured. So if nobody plays an instrument in your group, you feel free to download an app or look online for a sound, a tone that you can play. And the location you pick should be as quiet as possible. So I'm going to talk to some other teachers in the building and see if you can go to different classrooms that are quiet. I've asked our band director. You can, if you know him, you can go ask him as well. I don't know if the gym is available, and my classroom, of course, is available, but the more groups that are in my classroom, the trickier it is to run the experiment all at once, because everybody needs to be silent around during the experiment. Outside, I haven't had a whole lot of success with, because if there's any wind at all, even a light breeze, that can really affect the microphone. If it's not a windy day, you're welcome to try that. But yeah, so you need to choose an instrument and location. Be thinking about that ahead of time before coming to class, so when you find out who's in your group, you can quickly decide on an instrument and a location. Now, next thing we need to do is we need to take data. The way you're going to do this is you're going to use your app on your device and measure the data. Remember that for one thing, you should take at least 5 data points. Okay, so that's different. Say you're doing locations, that's 5 different locations. Or if you're doing a number of instruments, 1, 2, 3, 4, and then 5 of the same instrument or device to play the note. And the more you have, the better for your function fit. So if you guys feel like you're cruising through these, you can do a handful more in just a few minutes, feel free to do that. Another thing you should do is you should practice consistency, because this is kind of a convoluted, complex setup, and you want to make sure you're getting the same decibel measurement at the same location with the same number of instruments and all the conditions being the same. So you want to do that a few times, just maybe to kind of get your margin of error and see, you know, how accurate can you be. Another thing to keep in mind is you want to be as quiet as possible while doing this. So if something like, let's say, an air conditioner turns on in the room, you might want to go back and just do your data over again. Hopefully that will not happen as you're taking your data. So let me show you how to do this. These instructions here are going to be applied. I'm going to show you how to do this on the next screen with the actual app. So the first thing I would recommend doing is pausing the app. So you click the pause button, and then everyone gets real quiet, and you want to reset the app because it will go back down to 0. The maxes will go back down to 0. Then you're going to press the play button, which is the same as the pause button. You're going to press play, and you're going to be as quiet as possible here, because any noise could affect your experiment. And what you're going to do is you're going to play the note. So let's say you're playing a single note from 3 Chromebooks, you know, everyone's moving in position, you're going to play the notes, and then you're going to turn off the note, and you'll be really quiet, and then you're going to pause it again. So what happens is you played that note, but it's the maximum volume there is what you're measuring. I've found students in the past have tried to just look at the average or you know, where's the needle right now, what's the current number, but it's jumping around so much it's hard to get like a consistent data point. What'll happen is you'll have a single number for your maximum, and because you were quiet before and after the instrument was played, you'll be able to have a single number that you can use, and that's what you want to test, making sure you can get kind of the same situations, the same number there. All right. So let me just rewind and make sure we have that. So you want to be as quiet as possible. You reset the app, then you press play, then you play the instrument, and then you pause the app after you're done playing so you can check the maximum decibels. And in doing so, that's the best way to measure. If you want to play around with that with your app ahead of time, I would recommend testing that, seeing if you can clap or shout or something and get that maximum decibel measurement and see what I mean by that's really the only accurate, stable number that will sit there when you play with this app. So after you get your data, then you're going to analyze the data. You need to think about which of your variables is the independent and dependent variables, and you're going to put a table of the data into Desmos. Then you're going to find a function that best fits the data. And so I'm going to show that to you at the end of this. Actually, I'm going to provide a link for how you do that. Desmos has a good job of doing this. You might have one of two types of data rather, or one of two functions that will best fit this data. One is exponential and the other is logarithmic, because those are the two functions we're studying. So your data should match one of those two, and if it matches neither, we need to go back to the drawing board and think about what's going on with the data. You should also know how to do this in your calculator. I might make a separate video for that because this video is already getting long enough. But yeah, so I'm going to show you guys how to put the data in and find a line of best fit when you have that in Desmos. You're also then, after you type this in and find the function of best fit, you're going to create a presentation. And I might even recommend doing this as you go. Notice like some of the slides are your data slide. Just type it, have that be the place you record the data. So someone brings the Chromebook along to your location, you just save the data right there. You can make it look nicer. We're going to talk about the presentation in just a little bit. I'll go through the slides really quickly. But you basically will replace your slides content, replace my slides content with your slides content. So you don't have to do one for each group member. You can just choose one person's account to be the go-to account, but make sure as soon as you start, you share that document with everyone in your group so everyone can work on it, even if someone is absent. The presentation will also include a prediction of data points that you did not take. You'll do this at that point too, and if you have time at the very end, then you go back and test your prediction, all right? And you'll include the prediction versus actual slide. You'll see in a moment. So that's the project we're doing here, and your end result will be an equation and a presentation around that equation. So let's go through the presentation real quick just so you see what I mean. You'll have a cover slide, you'll have an explanation of what you did, because hopefully what you did was just slightly different than other people, and especially because there's at least two different kinds of experiments out there. Mine, I chose to measure how the decibels of monkeys, based on how many monkeys you have. Obviously, I don't have access to monkeys. Would be kind of cool. But there you go. I got monkeys on the left. That's my input, and decibels of the monkeys on the right, based on the number of monkeys. Here is the next slide. You're going to have your graph and your equation. So there's my equation. And my graph here, notice I did not label the axes. You should label the axes. Make sure that's on there. In fact, I might even include a screenshot so you have the Desmos table there on the left, and you can see the data with the graph. That would be nice. Then what you want to do is you want to do your prediction. So notice I didn't measure 7 monkeys. I only had up to 5 monkeys, but I want to say, hey, what if we had 7 monkeys? Well, based on our function, this is what we would have. So we predict that with 7 monkeys, we'd have 88 decibels. You can also make the prediction from the graph or the table in Desmos, and you should know how to do that. And like I said, screenshots are worth 1,000 words. So that's always nice to have, and people can see what they're supposed to do when they're doing predictions. And then you can, if you actually are able to go back and measure it, you can do a prediction versus actual slide like this. Notice the monkeys, when I put 7 monkeys in there, they just got all excited and got way too loud. But you also want to include why they might be very different. Or you might say something like, hey, our estimation was really, really close. That was awesome. We're awesome. Yeah. Yeah, this slide, again, is helpful to your presentation, but not strictly speaking required. Here's where you're going to have the conclusion. So you want to say what the equation is and what the variables mean. And feel free to have it short like I did here, although I need to include volume in terms of decibels and then M monkeys. So after you do all this, what you're going to do is you're going to include a set of 3 questions. All right, there are 3 slides with questions at the very end. And these are going to be questions for, if we get to it, if we're able to present to the class, then you're going to share these questions with the class and your classmates will answer these questions. So what's going to happen is you'll make these questions, and as your classmates answer them, then you'll walk around and help them, and then we'll see, and you guys will get in the hang of this, you'll then share the answer with the class. So what you need is you also need a slide with the answers on it, and just one suggestion, a pro tip if you will, is to have a blank slide between the question and the answer. That way if you accidentally click next, you just see a blank slide and not the answer. You'll notice that's why I do the estimations on Friday, have a blank slide between them. So here's my answer to question number 1. About 446 monkeys is how many it would take to reach 60 decibels. That is, the math here, I tried to do the math without an actual experiment, and I realized I did not have the right data matching up. That's okay. Your data will match your experiment. Then you can ask a question. So one thing I want you to notice, see my first question here, how many monkeys would it take to reach 60 decibels? The decibels is the output, so I'm asking for an input value, and the answer is the input. Here I have an input value, how loud would 99 monkeys be in decibels, and I'm looking for an output. So you should have one question that's looking for the output, one question that's looking for the input here, and I did not answer this one, but again, you will. And the last one, you can come up with a creative question, but you could also have another input or output question if you want. So this is the setup, and let me show you how to type this into Desmos. All right, so notice I've graphed the data here in Desmos. I've scaled my axes. I've labeled them as well. Very important. And so I'm going to try to find a line of best fit. There's a way to do this on the TI graphing calculator as well, but what I want to show you guys is this equation here is how you type a line of best fit. Now, I'm showing you a line as an example because this data will not be linear, or should not be linear. Notice I have M and B. Those are 2 variables that I have not defined anywhere else. Okay, so I don't have M equals anything anywhere. And that way this knows, oh, M is this, B is this. Also notice that I've got X1 in the column of the data table, and X1 is the variable that is in the equation. So don't just type Y and X, type Y1, X1. So Y1 and Y1. The nice thing about Desmos is you can just type Y then followed by a 1 and it'll be fine. And the last thing you need to see is instead of an equal sign for this to do a regression, you need a tilde. And the tilde, it's right under the escape button usually on the top left of a keyboard, right to the left of the 1 on the keyboard. You can type that there, and that will give you a line of best fit. Some other things you guys, I believe, have learned before about R and R squared values. R squared especially is a good way to measure how accurate a function fits the data. So that is one way to say, hey, this is the best function to fit our data because it's the smallest. Or sorry, it's the largest. You want it as close to 1 as possible. 0 is a terrible fit. So yeah, you can see my line here has a 0.78 R squared value. That's not that great, so we can probably find something better. It does tend to increase, but you see how there's a curve here? Okay, that curve we definitely want to fit. Another thing with these, I can type in. You really have to know how. Like if I think it's just a directly proportional graph, and I just think the b, the y-intercept should be 0, I can leave off b there, just type mx1 on the right side of that function, and it'll leave b blank and try to fit it as best as it can with m. So the nice thing is there's a lot of versatility here that you can't do with a TI calculator, but you also with great power comes great responsibility. So you have to know your functions and what exactly you want to fit here. So for example here, this is the generic form of an exponential function. I could up there put x1 plus c or something like that up in the power, but I can show you guys. This actually covers that as well. Let me talk about that another time. Log mode, we're not going to talk about quite yet. You can look at that question mark if you want to, but see this r squared. Oh, that might be a little bit worse. It should be a little better. 7, 8, no, it's a little worse. So Yeah, my data, the data I took, probably is not going to be an exponential function then. But you notice it gives me what A is and what B is, and you'll plug that in as well. And you notice it doesn't really seem to fit any of this data real well there. So here is my data with a logarithmic function. With our logs, if you just decide to try a logarithmic function, which you should certainly try one, you can just put A times the log and then plus B. I'll go ahead and tell you the parentheses are right here, so that plus B is on the outside of the function. So it is moving the function up and down rather than left and right, which is very important to notice. Also look at my r squared. That is clearly the best r squared of the bunch, and you can see it in the data points. It basically goes through or right next to every point, so that's a really good fit. So again, make sure you're typing x1, y1 and the tilde, and you can type in whatever function you want on the right there, though my advice would be your data is probably going to be exponential or logarithmic. So thank you for watching, and I would even recommend having this video on standby as you're doing the experiment, especially as you're filling out the project. If you get stuck on anything, that way you don't have to run and ask me if I'm busy. You can just consult the video. All right? Thanks for watching.